All right, everyone. Thank you for your patience and for hanging tight. I'll just say it one more time, just in case. If you are going to the caregiving session and you want to watch the caregiving session, you will have to click the link in the chat and go to a different room. For the next 50 minutes, this room is devoted to the K-12 segment with Little Shop of Physics. So the topic around this little workshop is resilience in movement. Our bodies provide a physics experiment in understanding the benefits of resilience in movement. The more movement you have at your disposal, the greater ability you have to move through stressors in your life or just keep moving, period, even when we don't know what the future holds. So I will now turn it over to Heather Michelock, Assistant Director of the Little Shop of Physics at CSU, and she will introduce us to her students, her undergrads, and the little workshop we're going to be doing. So thank you, Heather.
Hello, thank you. And I want to take some time to introduce the crew. So we're part of the K-12 session. I have an awesome crew with me today. So we're just going to do quick introductions. My name is Heather Michelock, and I'm the Assistant Director of Little Shop of Physics. And when I was in college, I did a physics major, but I wanted this job. So now I have this job, which is pretty sweet. And we can just go around the room and quickly introduce ourselves.
Hi everyone, my name is Reagan. I'm an intern with the Little Shop of Physics, and I'm studying psychology here at CSU.
My name is Emma. I'm also an intern here at Little Shop of Physics. I'm studying biology education, so I'll be a teacher one day.
And my name is Maud. I am also a intern with Little Shop of Physics, and I am a senior studying neuroscience here at CSU.
This is awesome. So I would say for us, and it's interesting, so we were brainstorming initially about this resiliency and movement in our bodies, but I know for us, we use our bodies to do a lot of things. And in Little Shop of Physics, what keeps us resilient is our curiosity and our wonder. So we love to explore stuff, try stuff out, and each of us has some different hands-on materials to show you today. And all this stuff you're going to see, we have a handout that we can give you that has links to videos that shows you how to do everything that we have. But all this stuff you can do yourself at home. This is simple materials. A lot of this we got from the grocery store, the hardware store, and even the dollar store. Each of our crew has a theme about what makes them resilient in science and what, as a woman, what helps keep them going. And speaking of resiliency, I'm seeing poor Emma is straining over here.
My hands are starting to cramp up because I've got this experiment here. It's a ton of popsicle sticks all woven together. I don't actually know how many, but I should have counted as I was doing it. And the reason I have to hold on so tight is because these wooden popsicles are bent in a way where they're storing a ton of elastic potential energy, which means that energy has to go somewhere as soon as I let go. So, can I let go?
Go for it, Emma.
Yeah, so as soon as I let go, all that potential energy that was stored in these bent wooden sticks got converted to kinetic energy. And so they all went flying everywhere, which is super fun to clean up. And that'll be great for later. But yeah, so that was a cool physics demonstration. I've got a couple more here today. One that I really like to do, thank you, Maud, is the density bottle. And so what I'm going to do is I am going to mix together alcohol, which I have 99% isopropyl alcohol here, but this should work with 70%, which you could get at the drugstore. And then thank you, Maud, for bringing me this beautiful tiny measuring cup. We've spent a long time on this experiment. And
oh my gosh, so many years. So many years.
Because it doesn't always work unless you get the measurements correct. So we spent a long time perfecting how much of each ingredient we're going to put in here. which is hopefully why it'll work today. We're hoping. So I have lines drawn out on this water bottle
Oh, nice. That's well played. Well
just so
played.
that I know exactly how much to put in. But a general idea is that it's usually equal parts water and 99% alcohol. So if you have the 70% alcohol, you might need a little bit more alcohol than water, which is handy to know.
I like this, but I know like isopropyl alcohol is water and alcohol, right?
Yeah.
Oh, so they mix.
So they mix, yes.
What?
So as you can see, just water and alcohol, it looks clear. It's not very fun right now. But I'm gonna put these food colorings in here, which again came with a lot of trial and error. But we figured out that the blue food coloring is actually alcohol soluble, so it only dissolves in the alcohol. And the green food coloring is water soluble, so it only dissolves in the water. So I mixed those two together. But because the alcohol and the water are mixed together, the colors just mix together. There's nothing much going on here. This just looks like I dyed some liquid, which isn't very cool. But now comes the fun part. If I add salt, and when I say add salt, I mean pour the whole container of salt into here.
Wow.
I could open it.
another one?
I might, no. Open it. Oh, I got it. So I'm just gonna put a ton of salt in here. I don't actually have a measurement for this. I just kind of go for it. But what happens is the salt mixes with the water, but not the alcohol. And what that does is it makes the water more dense. So the water starts to sit on the bottom of the bottle, but the alcohol sits at the top. And if I put this paper behind it, the color's not great. You can start to see the green is at the bottom, and the blue is at the top. Can you see that? Is it looking okay? I can definitely see it separating right here. There's a nice solid line. So yay, it worked. We have had some experiences where it hasn't worked. But here's all the salt water down here dyed green, and here's all the alcohol up here dyed blue. So we just watched the liquid separate right before our eyes. And I can even demonstrate the different densities. If I put little beads in here, they sit on top of the green, but they sink into the blue. I don't know if you can see that at all.
Oh, whoa.
So the beads are kind of just sitting in the middle there because the salt water is really dense, so the beads don't go underneath it.
Oh my gosh. I went swimming one time in like a really salty bath, like lake area, and I totally floated on the salt water. I could not get down.
Like the Dead Sea.
Yeah,
Oh my gosh.
yeah. So you can see there's a clear distinction between the blue and the green, which is really cool. And then I just have another one that we made earlier that's pink and blue. Kind of cool. Can totally see the beads floating around in there. And yeah, I also wanted to talk to, while we're setting up the next experiment, about my resilience experience. I liked school growing up in high school and stuff like that. And I was really good at school, but I was not good at chemistry. Like most classes were really easy for me, but however, chemistry was absolutely not. And I was really discouraged because I knew that one day I wanted to go into science. But I thought, oh my gosh, if I can't do chemistry, how am I going to be a science teacher one day? And one day I was in extra help with my chemistry teacher because I didn't know how to do the homework. And he said something to me and he was like, you know, Emma, you're one of my favorite students. And I was like, I didn't know teachers had favorites and that kind of thing. And I was like, why? You know, and he was like, well, you don't get the best chemistry grades, but you work really hard towards it. And that's something to, you know, commend someone for. So that's what made me feel strong and want to continue in science, even though it didn't come easy. But I'm under the impression that everyone has these magnets.
I think they'll be getting magnets in the
We'll
future.
be getting magnets in the future. So we have these little Shop of Physics refrigerator magnets. And they're really cool because if you've ever used refrigerator magnets, they don't sit on this colorful side. They only stick on that black side, which is interesting. And the reason for that is, if you can see in my magnet view paper, the pattern in the magnets makes these like little lines. I can see it. I don't know. It's hard to
Oh,
see.
yeah, it's a little hard to see, but it does look like stripes.
Yeah, there's like stripes in the magnets. And what that is like a little like horseshoe magnet, like in each
Wow, like,
line. Yeah, and they're kind of going like this and moving out.
I like this.
Yeah. So because of that, when you put these magnets together like this, they slide. They slide away from each other.
Oh, so like the north is sticking to the south and the south is sticking to the north, and so
Yeah.
then they just easily slide apart.
And they slide. However, when I put them like this, what you can do when you get your magnets, they like make a noise.
I don't know if that's gonna be
Yeah.
easy to hear,
Well,
but
okay, they make a noise and they're like harder to pull apart. You know, there's some resilience there.
I love this. And
So, more of a bigger demonstration of that.
oh, bigger.
Maud and I have these massive refrigerator magnets.
Are these the things they stick on the sides of cars?
Yes,
oh yeah, they are.
they
I
are.
didn't even realize that.
And it's the same concept as the small refrigerator magnets. We're gonna try and pull them.
I like this. You
I'm
can't
just
see
gonna
it.
drag Emma across the room.
They're on office chairs, so this makes it very nice.
Yeah, it's really cool. So, oh, they slide that way though.
Yeah. So they slide horizontally, but not vertically. These.
Yeah. Cool stuff.
All
That's all I've got. Yeah, Maud, stuff up to you now.
Alrighty, so I think what I've got going on first is a super cool thing I saw a video of before I knew that I could do it myself. So here I've got a little plate here, and that's cool. I guess I just need a new laptop because this glare is just not having a fun time. But I promise it's limes and lemons here, and I've got a bunch of highlighters. So if I take this old brochure from an old Little Shop of Physics open house, you know, no bias there or anything. But
Yeah.
so if I think that discover your inner scientist is super important at 11:30, I can highlight that. We all know how that one works, right?
Oh, I like that. That looks very exciting, what you want to go through there.
Oh yeah. But it turns out that maybe I wanted to go see the 1,000,000-volt Tesla coil instead, because
Oh, that's a cool one.
I mean,
Oh,
how can you pass that up? So I'm gonna try to get in real close here. So there's that guy. And so I just dabbed this paper towel on some lemon. And if I start rubbing the dabbed paper towel on my highlighter spot, and this is a little bit more difficult with this because it's like a laminated or like a partly plastic paper, but it's a little subtle, but it's starting to erase. And what's happening with that, and so you can see that it's erasing all of it onto the paper towel. Part of that, or this happens because of what highlighters are made of, doesn't react or doesn't like to react well with an acid, which lemons are an acid. And so the acid in the lemon is erasing the ink from the highlighter.
oh, whoa. So I've heard of these things called pH indicators. Is that?
So, oh dear. So this is like an at-home pH indicator. So it's like
Oh.
so this will detect acidity. So now I think I've got most of it off. We've got the time kind of still there, but that is all erased. And actually, if I tried to do it with the blue, the fun thing is that it tends to only erase the yellow part of
Oh.
highlighters. So if you have like a green or a blue highlighter and you try it, I think in my experience, it changes the color of it, but it doesn't completely erase it because it keeps it erases the yellow component, but not the other colors in the highlighter. And let's see if I can get any more juice on there. Or maybe the blue it likes. Maybe it was just the green. And the green one, no, it was the blue one turned green, but maybe this highlighter is just like extra cool. So there we go.
Wow.
Disappeared like magic.
It is like magic. So, you know, if you go to college and you decide you got to buy those you want to rent those textbooks instead of paying for them for class, you can still highlight in them as long as you go back through and erase it after. And you shouldn't get charged for that. You know, it's just a pro tip, life hack from a senior. Alrighty, and then next up, I've got this super cool thing with a sad-looking teddy bear in a bag, which is going to be an interesting bit. I think I
Barrington.
should probably point that way
Oh, yeah.
so that they can actually.
And you all can see, we're in what's called a little shop of physics live room. And you kind of get to see behind the scenes a little bit, which is exciting. And something that Maud is probably not going to share with you, because I know she's very humble about this, but she actually drew all the notes on the wall over there.
Yeah, this is one of the first things I did when I came to Little Shop of Physics. I was in robotics a lot in high school, so all I did was a lot of super geeky, nerdy stuff. Don't get me wrong, it was really awesome stuff, but I was so worried about not being like a typical girl, because girls weren't really allowed in science where I went to school. So I had to not be like a typical girl, and I wasn't allowed to wear skirts because, you know, I wouldn't be like one of the guys. So I couldn't participate in the science because that was kind of their world. So here, Little Shop of Physics kind of gave me that opportunity to be like, no, I'm still doing science, but I'm doing cool science where I can add some art and I can kind of get in touch with like other parts of my personality that I thought were important to me. And I'm kind of dressed a little silly today, but I presented this morning at a undergraduate research showcase. So I've got business on the bottom and party on top.
I love it. I love it.
So here I've got my buddy Barrington. I promise he's smiling.
He's got a snorkel.
Yeah, he
on.
does have a
He's
snorkel. He
He's got
can
a little
breathe.
snorkel tube that's coming out the top here, but the other end is connected to this vacuum cleaner that I have under this table here. Oh, geez. I don't want to knock him over because then he'll be extra sad. So I've got that, and let's see what happens when I turn the vacuum on, and it's going to be really loud, so I apologize in advance.
I'll mute it and save
Okay.
you all the vacuum noise while she does this, but let's see.
Must be really loud.
Oh, Barrington, buddy. Oh my God.
So I've got a squished Barrington at the moment. He's kind of re-inflating because the snorkel's helping him get some air, but now so the vacuum basically just sucks all of the air out, is increasing that pressure in there, and so poor Barrington got a little bit of, he got a big hug. He got a very, very big and tight hug.
I wish a hug from the atmosphere.
Yes, absolutely.
Very exciting.
I actually have been vacuum packed before, and I can say it's not a horrible experience. It does feel like a hug.
That's awesome. And it sounds like, and I know we were going to leave a little time for Q&A for each person, and folks are asking Maud, they about it. Could you talk about your research? Like, what is it that you present?
Oh, my research showcase. Yeah, so this morning I presented at a research showcase at CSU. It's called CIRC. I think it's Celebrate Undergraduate Research and Creativity is what it stands for. Yes, that is what it stands for. So I presented my thesis. For neuroscience, I do have to do a thesis, and my thesis was about concussion evaluation, so nothing to do with physics. Well, something to do with physics because the world is physics, but basically I developed, or the lab I work in developed a new measure for concussion evaluation. And so I was basically just analyzing some different aspects of that and our participant, basically demographic, and what that has to do with their concussion evaluation and their dual task ability. So basically your ability to multitask and all of that stuff. So it's it's a little complicated, but it's really cool to be able to do something that really impacts people's lives. It's very rewarding, I guess is the right word, to be able to go from not really being allowed to be curious to being curious enough to run my own project and have my own poster and everything at a showcase and be able to explain things that I actually came up with. It's not something I imagined for myself, or that I wouldn't allow myself to imagine for myself, if that makes any sense. But I think that both working here and being at CSU and just being a woman in STEM has really helped kind of like let me believe in myself and like let me like think of myself as resilient, as this person who is capable of doing things that are super cool to not just me and stuff like that. So that was very rewarding experience. Lots of work, but
Can you, I know they can't hear me as well. Can you ask them, like, does anybody have questions for you all?
oh yeah, does
Yeah.
anybody have questions for us? Shall we answer questions?
Yeah, you might have to say it again.
Alrighty. Oh
Oh.
dear.
And I think Emma, that somebody was asking about how do you know about the food coloring and which is which?
Oh my gosh, lots and lots of trial and error. We had to just keep testing it over and over and over again to try and figure out which ones were water soluble and which ones were alcohol soluble. Most food coloring is water soluble. It depends on the brand too. Like I use green and blue, but like a different brand of food coloring might work differently. In this one, I believe that we squeezed the juice out of highlighters.
No, my
so
poor
this-
babies.
This isn't food coloring, this is highlighter juice. So we just tested everything that we had until something worked, basically.
So that's
which
where
is-
my pink highlighter went.
The nature of science is that you got to be creative in it, and so
You get to explore, and that's the fun part.
yeah.
Oh my gosh. And what do you got next, Maud?
Oh, so just kind of going along with the we put Barrington under a bunch of pressure. And so now another thing that we use a lot of pressure with is a little silly, so bear with me. But you have it in your house, and I'm sure some of you can guess it with the shape I now have up here. Let's see if I can. There we go. That might look better. Yeah. Yeah, you just want to.
I got it.
Like
I'll
fall over
support
me.
you. I'll always support you.
I like this, supporting each other in science. Yeah, good.
So if you haven't guessed yet, this is my homemade toilet. It does not flush anything of the typical variety down there, just water, because that's very small. So this is a project that definitely gave me a bit of a migraine for a good semester. I had to go through 3 or 4 different variations of this to figure out what worked. I think I started with one of those like big jug gallon of water things, and I had to cut it. Those like 5-gallon bottles, I think. I don't know, I'm not
Like a
super
deep
familiar.
rock water.
Yes, like the deep rock, that's what it's called.
Yeah.
And I tried to use one of those, but I mean, as you can see, that was huge. So this is just a 2-liter bottle that I cut to kind of be more in the shape of your typical toilet bowl. And then I just have it. This is what your toilet plumbing looks like underneath. And the shape of it is actually more important than you know. So I have some colored water that I'm gonna fill up a little.
Ooh, it kind of looks like you have like some cleanser in your.
Yeah, I'm cleaning out the toilet. This is my oh, what is that stuff called? Oh, I can't remember. So
Yeah.
all right, so this is what your toilet's normally at, right? You still have water in the bowl. There's not a dry toilet bowl unless something's wrong, right? So the point of that is, so it'll usually be filled up so that the first line is filled up, and then this is the important part here. The water is just about to go over this here. And this is just my receptacle, so I don't spill water all over the little shop live room. But so you want this to be like just on the edge, if you will. But when you do your business and then you flush, so I'm going to add some water. If you add a consistent amount, then it starts to drain. and it should, and then it should start to flush. Or maybe not.
Oh.
That'll be useful. Sometimes you just gotta, there it is.
Oh my
So
God.
now it flushes all the way.
Oh, and why did it get sucked out the bottom?
And so that's just because you're creating a difference in pressure from here to where the water comes out at the bottom. And then as you notice, obviously a little bit of water still left there, but I can do it again.
Is it sort of like when you sucked the air out of Barrington, you had this like low pressure in the inside, higher pressure on the outside, so the end of this has high pressure,
Absolutely.
and then that, or low pressure, and then.
And then this is the high pressure and it just like
Whoa.
pushes it all out. And the key to this is kind of like a little bit of odd speed, because you want to, like, it happens fast and then it's done. And I don't know if you can hear, but there's a little bit of a gurgle, or if you've heard the gurgle happen at your toilet too, because you get some air trapped, and then it has to, when you have the pressure change and all of the water shoots down this way, then you have the water has to get pushed out this way. So it usually gets gurgly and weird up here. But yeah. So that's how your toilet works. If anybody was curious about that today, there's your answer. The things you learn how to do and look at, you know?
Oh, that's so amazing. Cool.
Oh God. I'm just gonna pour the
love it.
excess out here.
And as they're resetting up, I'm gonna redo. We have one speaker, so I'm gonna move it over to Reagan. And so we're gonna pin the video on Reagan here. And we might need to, let's see, add pin. And there we go. All right.
Hi, everyone. So the first demonstration I have for you, I'm going to use static electricity. I'm sure you've all felt static electricity, especially in the winter. You take off your nice warm winter cap and then your hair just goes zing. It sticks right to it. So that's because of static electricity. And the awesome demonstration I have for you today, I'm using styrofoam balls, a plastic container, and something really staticky. So this is just a little piece of furry fabric. And what I'm gonna do is I'm gonna rub all around the outside of the container. And I'm gonna rub all around inside of the container so that I can get all of this charged up with static electricity. This is kind of like if you rub your feet on a rug and then you touch someone else, you can shock them. That's kind of the same idea.
I like this. And I remember like this fabric is super staticky too.
Yep, it sticks to everything. Okay, yeah. So, oh, I didn't want to do it. So this is our first example of resilience in science. We are all experts at do-overs. If something doesn't work the first time, we have to keep trying until it does work, and also see what things we could change to make sure that it works the next time. So right now, I'm thinking that it might be a little dry in this room, which affects static electricity, or a little moist.
A
other
little
way around.
humid. Yeah.
If it's humid, you won't get as much static. If it's dry, you'll get more static.
I'm betting it's because I'm so excited. I'm just sweaty. And so like I'm increasing the humidity in the room.
I've got the sweat from the nerves this morning, so that's probably not helpful
Yeah.
either.
So we'll see if it works this time. Nope.
I saw
No.
one
I
right.
didn't
Like one was trying it.
Yeah, so what's supposed to happen here is the balls will actually float to the top of the plastic container because of static electricity. They're attracted to the plastic, which actually makes them defy gravity.
That is so cool. And do they, then I noticed too, sometimes they repel each other too.
Yeah, they do if they have opposite charges. Oh no, same charges, sorry.
It's all good. It's all good.
Okay, I don't know if this is gonna work.
We believe.
Oh,
believe
there
it.
it So we got one little ball that believed it could and had static electricity today. But yeah, this is pretty cool. And then the other cool thing is that if they do have static and you shake them, it discharges the electricity and they all fall.
That's
So
awesome.
that was my first demonstration. Next, I have a very cool magic trick to share with y'all. And this one takes a little bit of practice, but I definitely know that all of y'all could do it. So I have a 3-liter bottle. I have a wood hoop and a glue stick. So first I have to balance it all together.
Oh, did you just glue that on there?
No, I
Okay.
didn't. And the trick is I'm going to try and grab the hoop very quickly so that the glue falls into the bottle.
You got this.
I believe
you got
in you.
this.
You got it.
Oh no!
Whoa!
Okay, it doesn't always happen on the first try, but once you get the hang of it, it gets easier. And I have not done this in a few months.
It
So
never
we'll
happened
see.
for me on the first try, and I was doing it every day.
Yeah,
So
I
you
do.
got that going for you.
No, I'm usually pretty good at this. I got a lot of practice with some other boys and girls at another school. Okay, so I think this is balanced.
This is so good. It's so exciting.
The suspense.
Oh my
I'm
god.
shaking.
Shaking.
I'm ready.
I mean, this is like the definition, I think, of resilience in science. Like,
To just try again until you get it.
wow. Oh, you got this.
What if I turn it this way? Problem solving.
Oh.
Does that help?
Oh, there it is.
You have to get it in the right spot.
Yeah, this is tough because you have to be like perfectly centered, and these embroidery hoops are not always
Yeah, they're not always
like
made.
okay,
right.
100%
Okay.
circular.
You got this. You got this.
I was totally just building the suspense.
I
She knows
love
what
it.
she's doing. She works.
Okay.
Can I do this with like my dinner table and my dishes?
Yeah, so if you've ever seen the magic show where someone pulls a tablecloth out from dishes, that's also possible. We have a thrift store version, which we made. We went and got the nicest plates at our local thrift store, and we got a very slippery fabric, and we stacked all the plates up on top of this piece of fabric. And if you pull it fast enough, you can do it without moving the plate. Another trick is you don't want to pull up, because if you pull up, you're going to tip all the plates over.
Love this. Oh my gosh. This is so amazing, Reagan. I'm excited to see what you got cooking here.
Yeah,
This thing,
so
this thing on it. Oh my gosh, you've got clear liquid.
I have some clear liquid, which is labeled hot ice. This is actually sodium acetate. And I'm going
what
to
is
pour
that?
it into this beaker. And you're not going to believe what happens. So if I pour it in this tray,
Oh, I like the liquidy bit. Oh, do we need like a little?
we need a little pinch of something magic.
Oh, we need. How about salt? Would a little bit of salt that Emma has work? A little pinch, like, you know, we need a lot of salt in this thing. A lot of salt. Oh, maybe a little pinch of that in here. Oh,
I'll be right back.
yeah. I don't know where they
I
are.
forgot the magic.
We forgot the magic crystals, but we're gonna bring the magic crystals right back. And this is kind of fun. And while and I think Maud has. Oh
trying to
yeah,
make
that
it
was
cool.
good. Oh, I love it. I love it. So while Maud is did a nice camera angle on this. I love this. So Reagan's grabbing the crystals, and what this is it's a little crystal of the sodium acetate. And sodium acetate is basically baking soda and vinegar that's been boiled until it's like a liquid.
Okay. Then I've got my magical crystals, and you can already see the reaction that's happening here.
Whoa.
That clear liquid has turned into a solid, and it's all crystallized in the tray.
It's all frozen. So it went from a liquid to a solid?
Yep. So I can actually do it again.
Oh my gosh.
Because it happens pretty quickly.
Here it goes.
It's already
Oh,
started to crystallize as soon as it touches the other crystals.
oh my gosh. And Reagan, I'm feeling the back of this. This is hot. Is that why they call
Yeah.
this hot ice?
So that's why it's called hot ice. When the reaction happens, it releases a lot of heat. So heat and cold doesn't just come out of nowhere. It's always around us. So when this comes into a solid, that means that it has to get colder than it was before. So what happens to all the heat that was inside of it? It goes out into the atmosphere, which means it comes out. And if you put your hand right here, you can feel how hot it is.
Nice. And I think we have some reusable hand warmers
Yep.
to do this very thing.
So if you've ever seen something like this at the store, this is the sodium acetate reaction. You can boil them and use them again and again by breaking the little coin that comes inside, and it releases a lot of heat. That's why they're hand warmers.
Can you do that one more time, Reagan?
Yeah, it is a little hard to see because it's clear.
Whoa. Oh, I love that.
That's awesome.
And I'm sure we have a really good video of it on our website as well.
We do. This will be part of the link of awesomeness that you get.
Yep, but this is really cool. It reminds me of Frozen. The patterns that it makes looks like the ice that Elsa shoots out from her hand.
Oh yes, totally.
Like when she makes her snow ice castle.
And something I don't know because it's been forever since I've had chemistry, but I know like
I don't want to talk about chemistry.
but like water makes a six-sided thing. So like with sodium acetate, like maybe it has the same six-sided thing, or maybe it has more sides because that looks like it has more bits to it. But I don't know. This is a good like trying sciencey stuff out. And Reagan, I don't know. Do folks have questions for Reagan, or do you want to tell us a little bit more about like what makes you resilient in science? Like,
Yeah, I could definitely talk a little bit about my story of coming to college. So I'm actually a first generation student, which means that my parents didn't go to college, but that hasn't slowed me down at all. It's been a wild ride to get here, but ultimately I couldn't have done it without my love for science, because that's what really pushed me to go to school and learn more, was that I really like science. So I wanted to know more about it, and I knew that that's what I wanted to do in the future with my career. And the only way to do that was to go to school. So I basically said, okay, I need to go to college in order to do what I want to do. Let's do this. And I figured it out with the help of some amazing people. And yeah, the rest is history, I guess. I'm graduating this semester and I'm super excited. So yeah.
That's awesome.
awesome. It's been fun to have you on the team. I'm sad like Maud is graduating and leaving us. Reagan's going to graduate and leave us. We have Emma for another few years. So if you're out there and watching this and you're like middle school, high school, think about you could come join us. So if you choose Colorado State University as your college, we'll give you a job and we will pay you to do all this stuff you're seeing today. So think about that. Offers on the table. You could just come and you say, hey, Heather, you remember when you offered me a job? And I'll say, yes, come work for us. Cool. So I guess we're on to the last part. I get to bring up the rear, and I'm gonna have Reagan help me out a little bit on this. So some of the things that make me resilient in science, I was very fortunate to have a mother who became a pilot and flew for a living for a long time. And she always taught me to just like try things out, be curious, take things apart, you know, just try things. And if you fail, that's okay. Like, what did you learn from that? And you got to keep going. And that has stuck with me through my life. And I realized, like, as I got on in age and I was exploring and being curious about things, that what made me really happy is seeing awesome folks like you see in the room today, getting curious and exploring and trying things out. And that's what keeps me going. And learning about cool people in science who also like to try things out. So one of my favorite folks out there is Annie Jump Cannon. So she was an astronomer and she cataloged over 3,000 stars, which is amazing. Can you all imagine like staring at plates? No. And she looked at
3,000? No.
Over 3,000, yes.
I can do one.
Yeah, and she came up with the scheme that we use to catalog stars. The catalog got named after somebody else, but she's the one who did all the work. So she did use something like this, and this is something snazzy that the school groups that joined us today let us know, and we can send you some awesome rainbow glasses. So she had something similar to these rainbow glasses, and you can kind of see we're kind of shimmery here. And in fact, I think I have over there is a light. So let's bring the light to the middle of the table. And I can show you what the rainbow glasses do. And so you can see it breaks light apart. And so you can see that there's a rainbow of colors. You can see on the outside is red and the inside is purple. But people have asked me, well, Heather, what if I don't have these awesome rainbow glasses, but I want to do this? Well, you can go to a thrift store, or if your parents have really old Join AOL online CDs, you can take one of those. Don't take their nice CDs that they're storing from back in the day, because that might make them sad. Yeah, the Beatles CD, that would be sad. So you're going to take this CD and you can scratch it with something like, I've got a sharp key. Oh, maybe that one's not as sharp. Oh, there we go. That's nice and sharp. So I scratched it. And now I'm going to take a piece of duct tape. And any kind of sticky tape will work for this. We just happen to have a lot of duct tape in the little shop. And you can see I pulled the shiny bit off this CD. And so now got some tape. I do have the technology, and with Reagan's awesome help, I'm going to tape this CD onto my camera. And it's kind of neat. Oh, looks like I did a terrible job of that. Let's try that again. There we go.
It's just the brightness is affecting it.
Oh, I see. There we go.
Yeah, so Heather just made her own rainbow glasses. How cool is that?
I just love it. And it's kind of fun. You can hold them up to your eyes. Like we made CD like rainbow glasses. They look awesome. They're super flashy to wear.
And someone asked, why are there more rainbows with the rainbow glasses? Do you want to tell them about the diffraction gradient?
Yes. Oh my gosh, I love this question. So on the CD, this looks kind of like your old record player record. So there's one groove that kind of goes around and around and around and spirals outward. So it's a series of lines. So you can think of, there's a series of lines on the CD that breaks up the light. With my super rainbow glasses here, this looks more like a screen door where it's these lines this way, and then we have lines this direction, and then we have lines and an X. So there's several, they call them diffraction gratings because they're literally a grate and they diffract, so they break up light. And so that's why you get it. So they want like more bang for your buck if you're getting this one. So they give you more diffraction gratings. With the CD, you get the one, which I think is kind of nice for showing what we're going to show. So Annie jumped Cannon, she looked at all these, like, they're called star spectra. And what it is like the rainbow from a star. But she didn't just see this. She saw what the star was giving off and had in its outer layer. So if I have a star.
Wait, Heather, so you're saying stars give off different colors?
Oh my gosh, yes, yes. They're different color stars. So there are blue stars. There are yellow stars. And I know you might think our star is a yellow star, but actually our star is a green star, which is kind of cool.
I didn't know that.
I know, right? And then there's red stars out there like good old Alpha Centauri, our nearest stellar neighbor. So let's see, if we had a blue star, what would that blue star look like?
Wow. It changed the rainbow.
And it changed the rainbow. And so like we can see blue. Oh, blue takes away yellow. Oh my gosh. Now if I have a yellow outer layer, what's it gonna take away? Oh, there goes the blue and purple. Anybody who knows blue blocker sunglasses, that's why they're yellow.
Yeah, and if ever anyone has ever heard of the color theory in art, this is why they block out the opposite color on the color wheel.
Oh, I love that. And as we're doing this, so there's a great question about like why are stars different colors? This all has to do with how stars fuse. So they start off with hydrogen and they slam hydrogen together. And then eventually enough hydrogen makes helium, and then the star gets bigger and it can slam helium together. And then eventually helium slams bigger things together until you get up to iron. Iron is where it stops. Stars can't fuse above iron. So that's like what, number 16 on the periodic table, is that right? 26, thank you. 26 on the periodic table. So you know your chemistry better than me. So everything beyond iron in the periodic table comes from either supernovas, so stars exploding, or for neutron stars colliding. And they think that's actually where gold and platinum come from, is neutron stars colliding, and that's why it's so rare. But different elements burn different colors. And this one has all the colors, this incandescent light, but stars, depending on what they're burning, they'll look a little different.
So you're telling me that, what's her name?
Oh, Annie jumped Cannon.
So you're telling me that Annie Jump Cannon cataloged stars based off of their color and then got to know what they were made out of?
Yes.
Wow,
Oh
that's
my gosh.
amazing.
It's so cool. And later on, Cecilia Payne-Gaspachkin came along, and that's how she figured out that helium existed in our sun.
Wow.
Cool stuff. All right, so now we've got red. Oh, and the red is kind of taking out the green. Wow. So guess what the green's gonna take out?
Red.
Oh, the red. And this one even does a touch of the purple too.
Yeah.
So I think our green, maybe we're running into the food coloring thing like you were, where it has a touch of something else in there. It's also taking out this, not so bright. That's kind of nice.
Yeah.
But our star, it's green, turns out.
Wow.
But it also gives off a lot of yellow, so it kind of looks yellow. Cool. So I think we're good with this. I have one last demo to show you all, and it has to do with the.
You want me to take off the CD?
Oh yeah, we should probably. Good call, Reagan. I don't know what I'd do without these folks. These folks keep me straight. So I got this awesome laser here. Things like a lightsaber. It literally is a lightsaber, but it doesn't. cut through things, but it could cut through some things.
No.
I use this for astronomy, but I do need assistance with this. So we're going to put our little shop of physics balloon inside the red balloon. So I'm going to open this up and Reagan's going to help shove it in there for me. All right. Oh, and now we're going to blow this up. Now, the funny story about this is I did this one time for an online session, and Reagan can attest to it. Like, how many times did I try this?
A lot of times.
And it didn't work. And there were some very disappointed second graders on the other side. So I've learned to test out like all the colors of balloons that I'm going to use to make sure that they're all good. I think that's pretty good. So I've got this like fancy laser. I don't know, you feeling resilient?
Yeah, I can definitely hold the balloon, but
Awesome.
first I'm gonna put an ear protection.
Oh, good call, good call.
Hey, I didn't bring my ear protection.
Oh my gosh, you just have to go old school. There we go. So I've got this super cool green laser. And let's see. There we go. And I'll shine it like over on the wall so you can see this is a green laser there. And now I'm gonna point it at the balloon. What do y'all think's gonna happen? What does red absorb? Green. That was awesome. So it looks like our green balloon also absorbed enough color to pop it as well. So, but this is totally safe. So this is, I use this for astronomy. I wouldn't like point it in my eyes, but I can shine it on my hands and it doesn't, it gets a little warm. Like you wanna give it a shot. Yeah, see, totally fine. It's good. But the balloons absorb enough energy to then pop. That's awesome. So I want to thank you all for coming to our session. We had a blast doing this.
Heck yeah.
And because Little Shop of Physics just does more and bigger, and I don't know, we're like super resilient, wouldn't you say? We're going to have a big festival on Saturday, the Spring Science Extravaganza, and it's going to be in the Montfort Quad here at Colorado State University campus. We're going to be in between Clark, NESB, Animal Sciences, and Plant Sciences. Please check out our website for more details. We have maps. We're going to have super cool things. I don't know, you all want to talk about like what y'all might have there that you're excited about?
You guys go first. Oh my God, I think yeah, I'll be in the light and color zone. We've got some really cool chroma depth stuff, which you saw the cool diffraction glasses that Heather had. We have a different type of glasses that makes like certain colors look 3D. So we've got like a big tent that you can walk through where like all the different colors look funny. So that's cool. Just a bunch of cool light experiments. What are you doing?
I'm excited to see all of it, but I think I'm gonna be in the electricity and magnetism zone. And I mean, you can't,
Giant static spheres.
giant static
So,
spheres.
like the thing Reagan had, where we're talking a 5-foot deep ball full of static. balls.
Oh,
Yes.
heck yeah, yeah.
Come join us.
Nothing more exciting than electricity and magnetism. That's all the cool stuff, you know?
That's awesome. Reagan, what are you excited about?
I'm most excited for my creations. So I created 2 really big experiments that really seem to be a big hit with everyone that's seen them. They launch balls into the air and they are themed. One is a dog, like Clifford the Big Red Dog, and one is an elephant that I named Ellie. So these are giant structures that I built myself and they shoot balls into the air. So that's going to be tons of fun. I know that kids love playing with that. You put them in the mouth, they shoot out the top like 20 feet into the air. It's amazing. I would definitely say it's extravagant.
Join us. This will be amazing. I'm looking forward to seeing all the happy faces there. I hope to see you all coming and smiling and having a good time. Thank you.
Thank you all.
That was so great. Thank you guys so much. Those were so fun.
Welcome.
Okay, just give me 1 second here. There we go. Okay, so we're done. that was our last session for the symposium today. Little Shop of Physics, thank you so much. And then people are filtering in again from our caregiving session. So I'm sure that was an amazing discussion over there as well. We have some closing remarks from Dr. Mathiasen, and we have a poetry reading here in a moment. I will pass it over to Dr. Mathiasen, and then we'll kind of wind down for the afternoon.
Thanks, Hannah. This was such a great day. I cannot tell you how much I thank all of you for sharing your work and your stories with us today. It was great to hear all of your voices in what you do and how you are being so impactful out and across the world as a whole. I'd also like to thank those that were behind the scenes today, as well as Hannah, Joe, Westridge was there, Julie Moreno taking over as well for the second Zoom link. Thank you both for doing that. As always, the WISS board for all of their input for our program for the year. And then, of course, our sponsors. I would be amiss if I didn't have incredible sponsors for WISS as well, and how much we really appreciate their continued support of the work that we've been doing. And then, of course, a special thank you to our WISS community. Thank you all for coming. We certainly couldn't do this without you being here with us as well, and leading us on this journey that we continue to take. So I also want to share with you that in 2023 will be WISS 10th anniversary. And so we have already scheduled our WISS event, which will be March 8th. So please mark your calendars. We'd love to see you there. We will be in person versus virtual. So we are super excited to be able to go back to in-person work and seeing all of you and being able to have some really incredible interactions with the community one-on-one. Let's see, what else? October, November, please join us. We will be hosting a showing of Dear 139 with WISS Innovating Minds, and that as well will be in person. And so we look forward to having you gather there. All of those events will be on our website for the future. So please continue to join us for what we are providing and bringing together as community for all of us. So this brings me to the ending of the program. We are super, we're just really happy to have Robin Walter. She is a graduate of CSU. She's also a poet, and she has brought together, I think, some of her own original work and some other readings to close us out. So Robin, please take over for us to close out our day.
Thank you so much, Dr. Mathiasen. I'm so honored to be here and humbled to have been invited to be a part of this wonderful gathering. And I had the good fortune to hear so many presentations that I feel energized and inspired. So thank you everyone for sharing. Among the many little snippets that I'll be taking home is that stars have emit different colors. That's so cool. I didn't know that. So I'll bring that into a poem in another time. And two, I'm so moved by how supportive this community is of one another, and just wanted to relay that how consistently I'm reminded that resilience is so tied to community, and how important that is to the fabric of resilience. So my charge from Dr. Mathiasen was to gather poems that speak in some way or another about resilience. So I have to share 2 of my own poems and 2 poems that I think speak towards that theme that I love, that I'll share with you. Thank you again. This first poem is titled The Beginning of July. The beginning of July. I thought I heard my mother crying. This is, I don't know if I clarified, this is a poem of my own. The beginning of July. I thought I heard my mother crying, but it was just the sound of the cold creek emptying. At sunrise, the chickadee pulls the morning open. At noon, shadow of chokecherry slips across collarbone. There are so many ways to want. The wren weaves small feathers and a little twine into her nest. The black heifer lows for her calf drifting down valley. She looks at me, I pretend innocence. Flurry of small butterflies stills for a moment on the purple phlox, wings peeked into V's like the paper planes we sent stuttering between desks when we were young. We were practicing love, then grief, then both. Pronghorn, honeybee, ovum. Each body decides its own way through wind. The woodrock corral finally gives and leans heavy to the hoof-stamped ground, as if in prayer. The aspen leaf rivers the light. The horse arches her neck, whinnies, picks her legs up tight and high. The brook trout darts between cup bank and stone, and the wren buries her body deep into the bowl of her nest, pretends her hollow bones heavy. The pine needles gather pollen across the length of their spines. A flicker shifts, a yellow cloud blooms. Blue stem, meadowlark, loam. Spurge staked more hillside as its own this year. Muddy lip of waterline lower than last. Bloodroot and trillium. Little songbirds make slender shadows. I pretend my hand a nest. In the slope of hill where we buried my uncle, we leaned antlers careful and neat against moss-spottled stone. Prairie smoke, pasque flower, buttercup. These the sounds we fold into prayer and press into streams. Penstemon, lupin, balsam root, tiny heart, sorry, blood clot. Heat lightning stitches across the wide belly of sky, little mercy. Motherhood, a friend told me, will break the mind clean open. This morning, held the empty hollow of a robin's egg in palm, tried hard not to crush it, crushed it anyway. The seed head pulls the Timothy sideways into an arc, forms a little door to open. This the season of miller moths and sorrows edged into door jambs and windowsills. This morning, I prayed my body clean, clean and open. Here, the stream refracts morning into light. There, the hand gives way to body. Meadow, you are enough to live next to live by. And before I share this next poem, I'm so sorry, I realize my computer is about to run out of battery, so I'm going to run very quickly and get my charger so I don't die. But no, I won't die, hopefully, but the computer won't die. I'll be right back. Avoided a disaster, and I didn't die, luckily. This next poem is another poem of my own, and it's titled What Grammar for Prayer. Try the shiny black beak, the heartbeat, a little soldier. Try switchgrass, miller moth, moon. Try the moon is not a fist. Try a fist of wet lilacs. Try a fist of wet lilacs shaking. Try nest, stitch, twig. Try the whole thing backwards. Twig, stitch, nest. Try nest on its own. Nest. Try nothing, not naming at all. In this next poem is a poem titled Thanks, and it's written by W.S. Merwin, a favorite poet who everyone should look up. Listen. With the night falling, we are saying thank you. We are stopping on the bridges to bow from the railings. We are running out of the glass rooms with our mouths full of food to look at the sky and say thank you. We are standing by the water thanking it, standing by the windows looking out in our directions, back from a series of hospitals, back from a mugging. After funerals, we are saying thank you. After the news of the dead, whether or not we knew them, we are saying thank you. Over telephones, we are saying thank you. in doorways and in the backs of cars and in elevators, remembering wars and the police at the door and the beatings on stairs, we are saying thank you. In the banks, we are saying thank you. In the faces of the officials and the rich and of all who will never change, we go on saying thank you, thank you. With the animals dying around us, taking our feelings, we are saying thank you. With the forest falling faster than the minutes of our lives, we are saying thank you. With the words going out like cells of a brain, with the cities growing over us, we are saying thank you faster and faster. With nobody listening, we are saying thank you. Thank you, we are saying and waving, dark though it is. In this final poem, I'll share, and I'll preempt it by thanking everyone again for attending WISS 22. And again, thank you for inviting me to share these poems with you. This next poem and final poem is called Meditations in an Emergency, and it's written by Cameron Awkward Rich. Meditations in an Emergency. I wake up and it breaks my heart. I draw the blinds and the thrill of rain breaks my heart. I go outside, I ride the train, walk among the buildings, men in Monday suits. The flight of doves, the city of tents beneath the underpass, the huddled mass, old women hawking roses and children, all of them break my heart. There's a dream I have in which I love the world. I run from end to end like fingers through her hair. There are no borders, only wind. Like you, I was born. Like you, I was raised in the institution of dreaming. Hand on my heart, hand on my stupid heart. Thank you again, everyone, for listening to these poems, and I hope everyone has a wonderful day.
Thank you everyone so much for coming today. This was a wonderfully inspiring day with lots of inspiring conversations. We'll see you next time. Keep up with YSI, follow the website, attend the other Innovating Minds lectures, and we will see you at that movie screening in the fall.